In this example, we need to solve the equation, the square root of 3 raised to the x plus 4 equals 81 raised to the x. Well, what type of equation do we have here? Notice the variables are in the exponents, so this is an exponential equation. And how many exponential expressions do we have? We have one on the left and one on the right. The simplest form of exponential equation that contains two exponential expressions is one in which both sides can be written in terms of the same base. And if that is true, we can then use the one-to-one property for exponential functions that says if b to the x equals b to the y, then x has to equal y. Does that look possible in this case? Yes, because I can write the left-hand side with a base of 3, and I can also write the right-hand side with a base of 3. And here are some useful rules for exponents that are going to help me do that. And now let's look at the square root of 3. I need to write that as a fractional exponent. I need it 3 raised to a fraction. So the nth root of a to the m is a raised to the m over n. Notice the index goes in the denominator, the power goes in the numerator. So in our case, when we have a square root, we're too efficient to write the index of a 2, and we're also too efficient to write the power of 1. So the square root of 3 is 3 raised to the 1/2 power. Index goes in the denominator, power goes in the numerator. So now the left-hand side of my equation is going to be 3 raised to the 1/2 power, all raised to the x plus 4, equals, now I've got to work on my 81. 81, remember, is 9 squared, or 9 times 9, and 9 is 3 times 3. So 81 is 3 raised to the 4th power. So I'm going to have 3 raised to the 4th power, all raised to the x power, as 3 to the 4th is 81. Now I'm going to use the power rule that says a raised to the m, all raised to the n, equals a raised to the m times n. So in my case, I'm going to get 3 raised to the 1/2 times x plus 4 equals 3 raised to the 4 times x, which is just 4x. Now my bases are the same, so my equation is in this format. Since both of my bases are 3, I can set my two exponential expressions to be equal. So I know 1/2 times x plus 4 has to equal the other exponent of 4x. So now I have a simple linear equation. Let's get rid of our fraction. I'm going to multiply both sides by 2. So my 2's reduce on the left-hand side, and I just get left with x plus 4 equals 2 times 4x, so it's 8x. Subtract x from both sides. I get 4 equals 8x minus x is 7x. Divide both sides by 7. So I get x equals 4/7. This was an exponential equation. I do not have to check for extraneous solutions, but if I wanted to check this, I'd check it on the calculator by finding the square root of 3 and raising it to 4/7 plus 4, and see if it equals 81 raised to the 4/7 power.